Hello everyone. In the last video we used Niagara to create the text effect of the neon sign, and in this video, we will create the text scrolling effect based on it. Of course, we also added some other user parameters to control the size of the neon sign and the size of the particles in the level, as well as the flicker frequency of the particles. We add the corresponding user parameters in Niagara and then set it in the blueprint, just like we did before. Of course, there is also a color. If we don't want this effect to use random colors, we can add a user parameter linear color, so that we can set the color of the neon sign directly in the blueprint. We can take a look at it in the level, which is such an effect. Okay, now we are going to make the text scrolling effect. Open Niagara. To make the scrolling effect, we need to add a kill particle in volume. Use the shape of a box to simulate the range of the neon sign. The x-axis can remain the default, because the axes used by the neon sign in Niagara are the y-axis and the z-axis. Set these two values to 1000. These two values are not absolute. We need to adjust them according to the size of the sign. If our sign is a little bigger, we can set this value to a larger value. Then we invert this volume so that the particles outside this volume will be deleted. Okay, now we can't see any difference, but when we add the change in position, make vector, just move the position of the y-axis. Yes, we can see that when the particle moves outside the range of the box, it will be deleted, so a scrolling effect is created. We need to set the starting and ending positions of the particles and give it an animation effect. So using lerp to control is a good method. The starting position is -1000, and the ending position is set to 1000. Alpha is used to adjust the speed of the text scrolling. Usually, we use curve to make it, such as from 0 to 1, but it should be noted that the curve index here, we cannot use particle age, because it operates on each particle separately, and what we need is to make these particles as a whole and uniformly modify its parameters. So we need to use emitter age. That's right, because emitter age uses real time. In the curve it means that it takes 1 second to make the value from 0 to 1. So these particles move faster. The effect does not look very good, and it cannot be looped. Of course, we can also use looped age, or normalized loop age, but it is still a bit troublesome to adjust. So here we can use a method that is often used in material, add a frac. The value of frac is age, so it will always cycle between 0 and 1, and then we can add a multiply float, use a constant to control age's speed, such as 0.2. Okay, now let's take a look in the level. The flickering frequency is a bit too slow, so the effect doesn't look very good. We adjust its frequency to 5. Yes, that's right, a text scrolling effect from right to left. We can try to enter a longer text and see. Okay, due to the size of the texture, the offset of the particles is not enough when displayed in Niagara, resulting in the text scrolling effect not working well, so we need to set the starting and ending offset positions. Create two user parameters offset start and offset end. Find A and B. A is offset start, B is offset end. Okay, we go back to the blueprint and add two new float Niagara variables here. The target is Niagara system, and the variable name is offset start and offset end. We need to scale these two input values according to the texture size and the grid location in Niagara. By default, the texture size is 100, and the XYZ dimensions of the grid location are 10. The value of this dimensions is the multiple that needs to be scaled. That is to say, if the image size is 100, then the distance that the particles need to be offset is 1000. So here we need to get the size x in RT and multiply it by 10. The starting position is the negative direction of the y-axis. So here we multiply by -10 and connect it to in value. And then the end position is the positive y-axis, which is 10, and it is connected to in value in the same way. Oh, by the way, here we use size x, that is, dimensions to control the overall size of the neon sign, so we can directly multiply it by size x. Then multiply it by -1, and finally connect it to in value. The same is true for the y-axis, so that no matter how long our text is, it will scroll correctly. Yes, this is the effect we need. Okay, if we want Niagara to have a vertical text scrolling effect, we first modify the text and press Shift and Enter to wrap the text. Okay, back to Niagara. We can replace the nodes on the y-axis with a z-axis in position offset, and then delete the y-axis, so that it is a vertical text scrolling effect. Of course, these can be adjusted according to our own needs. Okay, so that's all for this video. I hope you like it. Bye.